Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to look at some different angle relationships, and we're going to be able to utilize these later on in some proofs. So they're going to go in our toolbox where we can pull them out and use them for reasons or justifications as needed. Before we start though, before we jump into new material, let's do a quick review of some old things and take a few minutes to pause the video, work through these problems. Then come back and join us for a discussion. All right, so for the first triangle, we have three variables to find, x, y, and z. And you could either find x or z to begin with, but you had to find one of those before you found y. So for x, I'm just going to start with that. I have three angles here. You know what, I'll just highlight the triangle. So x is the third angle of a triangle. So I can use the triangle sum theorem. And I'm going to get x is equal to 76. Once I find x, I can either then find y or z. I'll just go with y. We'll work our way across. Y and x form what we call a linear pair. So we've got 76 plus y is equal to 180. That means y is equal to 104. And now you have several different ways you can find z. I'm just going to use the smaller triangle. This one right here. Another triangle sum theorem. So I have 31 plus 104 plus z is equal to 180. I get 135 plus z equals 180, and then I get z is equal to 45. We are done with problem number one. We'll go to number two. I need to find the value of the question mark. You have to be careful here. We don't know that any of these lines are parallel, right? You may think that 29 and the question mark are alternate interior angles, but we are not sure that these lines right here are parallel, right? We're not given that information, so we can't use alternate interior angles for that. What we can do is, again, use some triangle sum theorem equations. So I'm going to start with this angle right here. I'm going to call that x. So 29 plus 41 plus x, it's not an x, plus x is equal to 180. That gives me 70 plus x is equal to 180, which gives me x is equal to 110 degrees. Let me replace that with 110. Next angle relationship, I know that these two angles are vertical, so they have to be congruent. So that means that we have another 110 degree angle up there. And then I can set up another triangle sum theorem. We use this theorem a lot. So I get 143 plus the question mark is equal to 180. And then I get the question mark is equal to 37, which would give us answer C. On to the third one. Let me get rid of some of this in case we need the space. Again, a couple angle relationships we need to be aware of here. We have these two angles, which again are vertical. So I'm just going to replace that other angle with 35. Then I can use a triangle sum theorem to figure out x. So I have x plus 35 plus 100 is equal to 180. I get x plus 135 is equal to 180. And I get x is equal to 45. So I can replace my x with a 45. And then I have a linear pair, right? These two angles form a linear pair. So I have the question mark plus 45 is equal to 180, because linear pairs sum to 180. And I get the question mark is equal to 135. I will say that we will have an easier way to solve number 3 by the end of this video. But that being said, let's talk about what some of these new things are. First, we're going to talk about exterior angles. An exterior angle is an angle that is outside of a polygon. It's an angle that is outside. It is formed by the side of a polygon, an extension of the adjacent side. Remote interior angles. These are the two angles that are inside a triangle and are not adjacent to the exterior angle. And then we have a diagram here. All right, so I have my exterior angle on the outside of the triangle. I have my two remote interior angles, which are the angles that are not adjacent to that angle, right? Angle C is adjacent to the exterior angle, whereas A and B are not. So that is why they are the remote interior angles. And this diagram has a equation that goes along with it, a relationship between the remote interior angles and the exterior angle. You can see it right here. It says D is equal to A plus B. If you can't see D, it's because I drew over it with the blue marker. So the triangle exterior angle theorem, the measure of an interior angle of a triangle is equal to the sum of the measures of the two remote interior angles. This is specific to triangles. It's not the case that if you have for instance, a square, right? If I have a square and I draw an exterior angle, okay, this angle is not equal to the sum of all of the other remote interior ones, right? Because then that red angle would have to be 270, which is clearly not. It's going to be 90. So this only holds for triangles. So you do need to put the triangle exterior angle theorem when you're using a proof. That being said, let's go ahead and prove this theorem right now, right? It's always good to understand where theorem comes from rather than just trying to memorize it or taking my word for it. So what we are given is that we are given a triangle BCD and with exterior angle A. And we're going to try to prove that the measurement of angle A is equal to the measurement of angle C plus measurement of angle D. I know I give you no help in this proof. You got to come up with the statements and reasons on your own. However, go ahead and try to do that. Go ahead and see if you can prove the triangle exterior angle theorem, and then join us for a discussion. All right, so there's a couple different spots you can start with. None of this information is going to be given, by the way. So I'm going to start with the measurement of angle B plus the measurement of angle A is equal to 180 degrees. Linear pair theorem. Now, you may not even know why we wrote this down, but when you're working with a proof, sometimes you write things down that you think may help you, and then it turns out that they don't, and you can always go back and rework it. But if you see an angle relationship in a diagram and you're not sure where to start in a proof, write it down and see if you can get anywhere from it, right? Or see if there's other angle relationships you can write down, and then maybe you'll see how they all need to come together. So that's what I'm going to do. There's another angle relationship, the triangle sum theorem, right? So the measurement of angle B plus the measurement of angle C plus the measurement of angle D is equal to 180. Triangle sum theorem. All right, so I have two angle relationships, and I have two equations that have 180 on both sides. So even if you're not sure where to go, right, you could try the transitive property, right? Both sets of angles are equal to 180, so why not set them equal to each other? Measurement of angle B plus the measurement of angle A is equal to the measurement of angle B plus the measurement of angle C plus the measurement of angle D. Transitive property of equality, or the transitive POE. Okay, remember I want to prove that the measurement of angle A equals the measurement of angle C and D. Well, here we go. I can subtract the measurement of angle B from both sides, and I am left with the measurement of angle A equals the measurement of angle C plus the measurement of angle D. And this is due to the subtraction property of equality. And we're done. We didn't end up needing this box down here at all. If you wanted to, you could put the... So I wouldn't mark it wrong. And to be fair, this would even be a little bit more formal of a proof. But you could certainly do triangle BCD and exterior angle A and put that as given, as long as you had this at the very top of your proof, which would be fine. And to be fair, it would make it a bit more formal. Okay, let's see what's next. Remember, we can now use the exterior angle theorem in a future proof, now that we've proved it. Let's do one of these problems. Let's do number 3. So now we're going to do a diagram problem that involves the exterior angle theorem. Okay, we're trying to solve for Z and then find the measurement of angle ACD. So let's think about what that theorem says, right? It says the exterior angle, which is 6Z minus 9, so 6Z minus 9, is equal to the sum of the two interior angles. Well, one of those is 2Z plus 1, and the other one is 90 degrees. So we can just say plus 90. And we can go ahead and solve. So 6Z minus 9 is equal to 2Z plus 91. Subtract 2Z from both sides, I get 4Z minus 9 is equal to 91. Add 9 to both sides, I get 4Z is equal to 100. And then I get Z is equal to 25. That's part of my answer, but not the whole thing. The measurement of angle ACD, that is the exterior angle ACD. So 6 times 25 minus 9 is equal to 150 minus 9, which is equal to 141 degrees. So again, like I said at the very beginning, we were going to be able to solve some problems more easily once we understood the triangle exterior angle theorem. All right. We do have a couple more theorems to look at today. Last page, though. The third angles theorem. So what I want you to do is just read the theorem on your own. Then look at the diagram, the hypothesis, and the conclusion. These angles right here, or these corollaries rather, are interesting, but they're not going to be ones that we are going to use in a proof. So read through them, but they don't have a specific name, and they're not going to be used in the proofs that I give you. So it's good relationships to understand. They follow from the third angles theorem, but not as important moving forward for what we're going to be doing. Okay, so the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles also must be congruent, right? So I have two triangles there. I have LNM, and I've got RST. Wow, that was a little poor. But they do share two sets of congruent angles, right? They share L, not share, but L and M in the purple are congruent to R and S respectively in the red. Well, based on the triangle sum theorem, right, we would always know that those third angles would always have the same measurement. So we could say that angle N is congruent to angle T. We don't have to go through the process of, finding different measurements. We just know that those two angles have the same measurement, and thus they would be congruent. So the third angles theorem is definitely something that you're going to use in proofs from here on out. So be looking for it. It's gonna make some problems much easier to solve, right? There may seem like a way, well, it may seem like we're unable to figure out how those last angles are congruent, but if we figured out the first two are congruent, then we can say that that last set automatically has to be congruent. The two corollaries here, the acute angles of a right triangle are complementary, right? That makes sense if one angle is 45, if one angle is 90, and we're talking about a triangle, well, the other two angles have to also add to 90 to fit the triangle sum theorem, right? If I have the triangle sum theorem, so they all have to add to 180. I have one that's 90, so plus D plus E. Well, if I subtract 90 from both sides, D plus E has to equal 90, and that's going to be true with every right triangle. The other one, the measure of each angle of an equiangular triangle is 60 degrees. We've already talked about this, right? An equilateral triangle, all its angles are congruent. Same with an equiangular triangle, because every equilateral triangle is an equiangular triangle and vice versa. There's only one option for the angles, right? If they all have to be congruent, well, they all have to be 60, because if they were all any other number, they would not add to 180. So again, those are something I think you already knew, or I think you would be able to understand. They're not ones that we're going to use directly in our proofs, right? There's not a specific name for them. We might use the information, but those aren't going to go into your bank of justifications or theorems or whatnot. All right, so let's see. Should we do number 5 on the video? No, we'll have you do that on your own, or we'll give you some time in class to do it. So that's going to wrap up this video. As always, enjoy the rest of your day, and I look forward to seeing you for our next lesson.